Hello, and welcome to TrainSignal. I'm Don Jones, and this is the Continual Maintenance lesson in the Database Administration Fundamentals course. In this lesson, we'll talk about 4 important maintenance topics: statistics, indexes, backups, and maintenance plans. Many of these are things we've discussed in previous lessons, but we'll sort of bring them all together in the form of a continual maintenance procedure. Like any complicated, complex machine, SQL Server does need ongoing maintenance to keep it running smoothly. While you won't have to change any belts or change the oil, there are some things you'll definitely have to do on a regular basis to keep the server working well. We'll cover some of the major tasks in this lesson. This is in addition to periodic tasks like performance tuning, which may not be necessary in every database scenario and which might not be necessary on the same schedule as some of this other continual maintenance. Your first maintenance item is statistics. SQL Server maintains a set of statistics on the condition of the databases and the indexes on the server. This is kind of like a traffic report. When SQL Server knows that things are congested, maybe an index is in particularly poor shape, it knows to take an alternate route when executing queries, such as maybe not using that index. Periodically updating statistics ensures that SQL Server is making smart decisions when executing queries rather than just blindly jumping on the highway during rush hour. Statistics are probably one of the most easily overlooked and yet most important maintenance aspects of SQL Server. Let's jump into SQL Server Management Studio, and I'll show you where you can set statistic maintenance. Now that I've done this big build-up for statistics, you're probably wondering how much of a maintenance task this is probably going to be. And the good news is, it's very easy. Just select the properties for a database, and on the options page, you'll see an option to auto-create statistics, auto-update statistics, and auto-update statistics asynchronously. Just make sure create and update are true. There are some performance considerations around leaving asynchronously turned on. You should consult the SQL Server documentation for more details on that and for help on determining whether it's appropriate in your given situation, but at least making sure that updates and creation are happening automatically, you're good to go. SQL Server will take care of it from there. Some people will tell you that there's a huge performance impact in doing that and allowing it to happen automatically, but most people don't really run into that in a production environment. If you're in particular types of production environments, you may want to turn that off. And again, SQL Server's documentation provides some guidance around that, but probably 99% of the time, just leaving those things to automatic is just fine and works perfectly, and it's one less thing for you to worry about. Indexes, as you learned in a previous lesson, are also an important maintenance item. Indexes in write-heavy databases can become fragmented very quickly, and that fragmentation means that SQL Server can take longer to read that information from disk, reducing the performance improvement benefit of the index. A periodic reorganization or rebuild puts messy indexes back into shape, and that will be reflected in SQL Server's updated statistics, telling SQL Server that the index is in fact a good one and may help improve performance. You can also specify a new fill factor to keep the indexes becoming fragmented quite as quickly. However, there are some trade-offs. Take a look at these two indexes. They both contain the exact same amount of information. The index on the top has been built with a 50% fill factor. That means that each page in the index is about half empty. Now that leaves plenty of room for new data to be added without having to split the pages and fragment the index. So this index will probably maintain a more consistent level of performance for a longer period of time. On the other hand, each of these pages is only half full, which means every 8 kilobyte read operation that SQL Server performs to read a page is 50% wasted effort because it's getting a half empty page. It means that SQL Server has to read 7 pages to get the entire index. And because this is coming off of disk, and because disk is typically the slowest aspect of SQL Server, this index is potentially making SQL Server a bit slower. The index on the bottom has been built with a 75% fill factor. There's still about 25% free space on each page, so there's certainly room for growth before index splits begin to occur. But now SQL Server only has to read through 5 pages to read the entire index into memory. So that means fewer of those slow disk operations to get at all of the data. And this really represents the trade-off between low fill factors and high fill factors. In a database that's being written to frequently, a low fill factor helps keep the index performance stable over time, although it might be slower than an index with a higher fill factor. It's safe to use a higher fill factor even in a busy database if you have a regular maintenance plan to reorganize and rebuild the index to take care of the inevitable page splits that occur. Index tuning is the process of determining not only how much you should fill your index pages, but what indexes you actually need. Index tuning is a very complicated balancing act between the priorities of reading data and writing data, and selecting what columns should be indexed is also very complicated. In fact, SQL Server includes an entire database engine tuning advisor to help with that process, although we won't be covering that in this course. Let's go back into SQL Server Management Studio and quickly review the process for rebuilding indexes. Now, when it comes to rebuilding or reorganizing an index, you'll first want to check your database properties. And actually, I like to do this with individual indexes. So let's go find an index. Here we go. Let's get into this set of properties instead, because this will not only show me the amount of fragmentation that I've got going on. I'm hoping for 0, because I think I've been good about rebuilding these automatically. Oh, 50% fragmentation. You know, 50% is a lot. We should actually do something about that. So let's go over here into Options. And you want to set a fill factor. This particular table changes pretty frequently in our application, so I'm going to set it to a 75% fill factor. Now, note that setting it here does not mean SQL Server's always going to maintain a 70% fill factor. This is just saying that when the index is rebuilt or reorganized, 75% is your goal factor. So I'm going to set that, and then right-click and rebuild. And that takes just a second. So it shouldn't, yeah, we've got 50% fragmentation status right there. So let's see what this does when I rebuild it. Now we'll reopen it and take a look at that fragmentation page again, see if it was able to do any better. Now, still a little bit fragmented. That means the data combined with the fill factor I've used, my pages are still only about 50% full. It just might not be able to do any better. Sometimes that's just because there aren't very many pages. In this case, you can see there's not a ton of data. There's only 2 pages in here, and so it's not able to make them both 75% full, so it's just kind of splitting the difference, and that's where the fragmentation's coming from. As that grows and more pages become involved, that number will probably go down simply because it's being spread across a larger number of rows. So that's not too bad, but that's where you would go in to set that. Now, if you look at a database like this one, and you look at the number of tables I've got, and you look at the fact that every single one of these tables has got 2, 3, 4, 5, 6 indexes, you might think, wow, I have to go through each one of these and rebuild them all? Not necessarily. In a little bit, I'll show you a way to help automate that and really do it for the database as a whole as part of a periodic maintenance task. Now, backups, which you've learned about in a previous lesson, obviously need to be performed quite regularly. You should balance your tolerance for data loss against your need for performance and your ability to provide the administrative oversight necessary to keep your backups running smoothly. Many organizations will take a periodic, say weekly, full backup, nightly differential or incremental backups, and often hourly or even more frequent transaction log backups. This all can make the restore process more complicated, but it does minimize the risk of losing data, and it provides a good balance of performance and overhead. SQL Server includes something called a maintenance plan, which is designed to help bundle up numerous different maintenance activities into a single, automated, schedulable package. Let's go into SQL Server Management Studio and see how to build a maintenance plan. Now, throughout this course, the examples and demonstrations I've been sharing with you, I've been doing on an Express edition of SQL Server. Express lacks some of the enterprise manageability features like maintenance plans. So in order to share maintenance plans with you, I'm going to switch over to a normal standard edition of SQL Server that I have running on the same computer. And you'll notice that it has a maintenance plans folder. I'm just going to run the maintenance plan wizard to get this going. It's going to ask me to name it. Sure, I'll call it maintenance plan, that's fine. This is not scheduled to run, so I'm going to schedule it to run, let's have it run on a daily basis. We'll have it run every day at midnight starting today. Perfect. So what do I want this to do? Well, let's have it check the database integrity. I'd like to rebuild all of the indexes. Let's go ahead and update statistics. I'd like to back up the database full and do the transaction log and clean up some of the maintenance history. So these are all going to be done in this particular order. Yeah, this is smart. You want to make sure that you're rebuilding the index before you update statistics, because part of what is involved in the statistics is the health of the index. So it makes sense to get the index healthy first and then have the statistics base themselves on that. So that looks pretty good. Now, what databases do we want to do this with? Well, we can select whatever we want to. I'm just going to have it do it to all databases on the system. And I will include their indexes because I want them all to be updated. And let's see, define the database rebuild index task. So let's do that with all databases as well. And we'll change the free space on everything to, actually, you know what, let's not do that. I see a lot of folks do this. Let's make everything 75, but you know, your database, some indexes are on tables that don't change all that often, and it makes sense to have a higher fill factor on those. For tables that are changing a lot, you might want a little bit lower of a fill factor. So you can go set that property for each index individually, and then just let this tool use that default amount of free space. And let's keep the index online while reindexing. That means the reindex task will take a little bit longer, but it means users will be able to still utilize the index while it's happening. So here's the update statistics task. Let's just run that against all databases as well. We'll update all statistics using a full scan. This is our backup, so we're going to back up all databases. And this is our transaction log backup. We will do all databases except those in simple recovery mode because there's no point in that recovery mode. Cleanup task, let's just clean up everything. Yep, that looks good. And let's email a report. No, actually, let's not do any reports at all. Okay, great. So we'll finish. And now it's going to sit through and create all of these tasks for us. Looks like everything's working okay, so we're good to go. Yep, there's our saved maintenance plan. We can close. And if we refresh this folder, we should see our maintenance plan. And of course, we can reopen that at any time if we need to make changes to it. In this lesson, we've covered the key elements of continual SQL Server maintenance. We talked about the need to maintain statistics, some of the maintenance concerns around indexes, and the need to perform regular backups. I also showed you how to bundle many of those up into an automated maintenance plan.